Hello everyone. Today we'll be getting into a new topic on side, 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 and side angle, side triangle congruence. So today's lesson is all about proving that two triangles are congruent. We've already done a lesson where we're able to show that two triangles are congruent by showing that all of the congruent sides are congruent and all of the corresponding angles are also congruent. However, that is a lot of steps. And we actually have some theorems that give us a shortcut to showing that two triangles are congruent. The first one is called the side, 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 or we'll just shorten that to SSS Congruence Theorem. And that theorem tells us that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So here we see that we have three sides of triangle ABC are congruent to the corresponding sides over here. So that means that these triangles are going to be congruent. So I could infer from this diagram here that triangle ABC is congruent to this triangle. However, remember that the order of my letters is super important. So the order I put my letters for the second triangle needs to match with the angles that they're going to be congruent to. So I see that A is the point that is between the 1 and 2 tick marks. So it's going to match up with the D. That's also connected by the 1 and 2 tick marks. B is between 1 and 3. And so I see that E is the one that's between 1 and 3 here. And then that leaves F. So let's go through some proofs of showing that two triangles are congruent. So again, number one, I'm given that KL is congruent to NL. And so I see that with my tick mark here. These two sides are congruent. I'm also given that KM is congruent to NM. And so all of that information is given to me. I want to prove that these two triangles are congruent, so that KLM is congruent to NLM. Well, we just learned from our side, side, side congruence theorem that if three sides are congruent to three sides of another triangle, then the triangles are congruent. Right now, I already have two pairs of congruent sides, so I'm just going to make a note of that on the side here. I have two sides already. So now I just need to show that this third side's congruent. Well, looking at my diagram here, I see that my third side, LM, is shared by both rectangles, or triangles. So since they're the same side, that means that it's going to be congruent to itself. So I have that LM is congruent to LM. And remember, that property that tells us that something is congruent to itself is the reflexive property. So I see from my notes here, I have side, side, side. So now I can therefore conclude that triangle KLM is congruent to triangle NLM. My reasoning is side, side, side. I have three sides, one triangle congruent to three sides of another. Okay, let's try another one. Here I am given first that AB is congruent to BC. So I have that here. So I already have one side in my given information. And then I'm also given that D is the midpoint of AC. And I want to prove that triangle ABD, so this left triangle, is congruent to triangle CBD, so this right triangle, or this triangle on the right hand side. So I already have one side. I now need to show that these two other sides are congruent to each other as well. So first, I want to use my given information. I'm given that D is the midpoint of AC. And so remember from definition of midpoint, that means that D is in the exact middle of this segment AC. So it's really cutting it in half. So that means that AD is congruent to DC. And that's just the definition of midpoint. So I have a second side. Now I again need to see that this third side is congruent. Well, again, just like we saw in that previous problem, I see that these two triangles actually share a side. And so I know from the reflexive property that BD will be congruent to itself. So I have my third side here, and that's just my reflexive property. So I have three sides. I have my S, 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 and so I can therefore say that triangle ABD is congruent to triangle CBD, and that's by side, side, side. Okay, now let's just look at some figures here. So I want to determine whether the congruent statement is true. Explain your reasoning. So here it says that triangle DFG is congruent to triangle HJK. And so I see that here. I see I do have three pairs of sides congruent to three pairs of the other sides, but I want to first check that these all actually match up. So I want to see, does DF congruent to HJ? So DF, that has two tick marks. HJ, that also has two tick marks, so we're good there. Now I want to look at FG. So last two letters. So FG has three tick marks. JK has three tick marks, so we're good there as well. And so that means that DG is 1, HK has 1, so we're good. So true. We have three pairs of congruent sides. Okay, now let's look at number 2. So number 2, I want to see if triangle ACB, so this triangle on top, is congruent to triangle CAD, so this triangle on the bottom. So here we're actually just given numbers for the sides. I want to see whether these all are congruent. So I see first off that my first two letters, AC and CA, that's really the same side. So it's going to be congruent to itself. Looking at this last two letters, CB and AD, I see that CB is length 7, AD is also length 7, so that one's good. But then now looking at this last side, AB and CD, I see that AB is length 3 and CD is length 4. So I don't actually have three congruent sides. So this one will be no. And I'd say don't have three pairs of congruent sides.